Hello everyone, welcome to Chemical Bonding YouTube channel. Today we are going to discuss a very conceptual questions from carbohydrate chemistry. So this is a very conceptual questions. Uh, there are many reactions in carbohydrate chemistry means glucose, fructose. There are many reactions of these molecules, but this is the very conceptual reactions and very important reactions regarding the competitive exam. So after discussing that reactions, we will discuss a questions that was recently asked in CSIR NET 2021 exam. So in that questions, same concept will be applied. Same concept will be applied. So first we will discuss the concept of that reactions, then we will see the uh, the question that was asked. So this is the questions that was asked recently in 2021 net exam. So now we will see the actual reactions and concepts. Let's start. So we all know that 1,3-diol, this is a 1,3-diol. So to block 1,3-diol, we usually used benzaldehyde, and to block 1,2-diol, we used acetone. So this is the reason why for 1,3-diol we used benzaldehyde and not acetone for blocking 1,3-diol. So if benzaldehyde react with 1,3-diol, then this six-membered ring form, and if we draw in a CR form, then in this case 1A is axial position to obtain the most stable conformation. Phenyl rest at equatorial position. But if acetone react with 1,3-diol, then in the six-member ring, 1-methyl should be in axial positions. So since there is no hydrogen atom, so 1-methyl should be in axial position. So their 1,3 diaxial interaction will be occur. That's why it's a less stable. So this is the reason why we used benzaldehyde always to block 1,3-diol. So now this is the structure of glucopyranoside. Means we all know that in my previous video I just mentioned that glucose, any aldoketose, they exist almost 99% in cyclic form. So this is the cyclic structure of glucopyranoside. Pyranoside means if that OH, that anomeric OH react with methanol, that anomeric OH, then that OMe is formed. If there is OMe, then it's known as methyl alpha D glucopyranoside. If there is no methyl, only OH, then it will alpha D glucopyranose. This is six-member ring. So this is six-member ring: carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So this is the planar structure. We can draw like that. We can also draw like that. So remember that in my previous video I already told that this is not any carbon atom. One can imagine that one can imagine that this is a CH2 group. No, this is not a CH2 group. To draw a proper orientation, we just draw like that. So this is not any CH2 or carbon group. So 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So the five OH group, and remember that we can draw like that. These are the OH group. These are the OH group. These are the OH group. This OH group is right side, Here also one OH group was there, but this OH group react with the CHO and form glucopyranose. Then if we react with methanol, then glucopyranoside form. So this is a six-member ring, means carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and oxygen. This is a six-member ring. This is not any carbon or CH2 group. So we can draw like six-member ring like that. This oxygen is here, and carbon 1, OMe is there. Carbon 2, OH right side, this OH. This is the symbol of OH. This is the symbol of OH. We draw like that. This is the symbol of OH group. So if we this structure, if we draw in Howard, this is the Howard representations. So right side means the OH group is lower, left side OH group upper, then again right side OH group lower, and this CH2 OH group. If we this CH2 group not right or left side. If we draw proper orientation, if we draw this structure in Fisher projection, then this CH2 group shifted to the left side, and that's why this CH2 group in upper side. So this is a normal drawing. So we can draw like that, alpha D glucopyranoside, and we can draw like in hexane, in chair form of six-member ring. We can draw like that, and also we can draw like normal six-member ring like that. This OMe group is below. For alpha D glucopyranoside means when the OMe group is right side, then this OMe should be below, and that OH is right side, so OH should be below. This OH is left side, OH up. This OH right side below, and this CH2 is upper side. So this is the chair form of alpha D glucopyranoside, and this is the chair form of beta methyl beta D glucopyranoside. Only difference is that this OMe group is, for alpha it is axial positions, or you can say below in planar six-member ring, and in case of beta D glucopyranoside, the OMe group is equatorial, or you can say the in the planar six-member ring the OMe group should be up, means above. So these are the same structure, but in different way. The methyl alpha D glucopyranoside, if there is no methyl group, only OH, since it is right side, then its name will be alpha D glucopyranose. Pyranose means there are six members. This ring is six-member ring. Carbon 1, carbon 2, OH, carbon 3, OH, carbon 4, OH, carbon 5, and this oxygen 6. So including oxygen, six-member ring. That's why pyranose. And since here OM is there, that's why its name pyranoside. So alpha OMe right side, chair form OMe axial, beta glucopyranoside OMe equatorial position, chair form OMe upside in normal cyclic six-member ring. So now let's move to the forward. So when this is the reactions, so just I mention all the structural properties of these two anomer, beta and alpha anomer of glucose, and particularly glucopyranose or pyranoside. When there is only OH group, free OH group, then it's called pyranose, and this OH group is protected as OMe, then it will its name is pyranoside. Pyranose means six-member ring. So when this glucopyranoside, I this OMe the bond is like that, means it is either below or up, means this molecule may be alpha anomer or beta anomer. If this OMe is below, then it is alpha anomer. If this OMe is above, then it is beta anomer. So to symbolize both anomer, I just put this type of bond for OMe. So if this pyranosite react with benzaldehyde in presence of H plus, so there are four OH group. So we just notice that benzaldehyde protect 1,3-diol. Benzaldehyde protect 1,3-diol. So if the 1,3-diol is in cis manner, then the protection or the reactions will occur easily. If it is a trans 1,3-diol, then obviously the reaction will occur, but the tendency for the reaction, but the rate of the protections is somewhat slow. So see, these are protected. So see, there are position 2 one OH group, position 3, position 4, position 5, position 6. So beside side by side I draw the chair form also. So see, we just notice that benzaldehyde react with 1,3-diol 1,3-diol. So from this structure we can easily say that since this 2 and 4 position, this 2 and 4 position, this OH and this OH are 1,3 position and cis in manner. So we can easily say that this 1,3-diol react with benzaldehyde, uh, and this 2 and 4 alcohol means 1,3-diol will protect by benzaldehyde. But let's see, in this structure there are another 1,3-diol, means this 2,4 hydroxyl group are 1,3-diol. Again 4, 5, 6, this OH and this OH also 1,3-diol, 1, 2, 3, 1,3-diol. But we cannot say this OH and this OH are trans completely, not it's completely trans. It is below, this bond is above, and this bond is plain. So this OH and this OH somewhat closer to each other. This bond is above, not the OH bond. This bond is above, and this OH in plane. So in this compound, in this glucopyronoside, there are two types of 1,3-diol. One types of 1,3-diol is completely cis, this 2 and 4. 2 and 4 position hydroxyl group are completely cis and they are 1,3-diol. So chance are there, this these two OHs react with benzaldehyde and protection occur. Another chance will be there, this OH and this OH. These are also 1,3-diol, 1, 2, 3. These are also 1,3-diol. So, but these are not properly cis orientation. So one can easily say that these 2 and 4 hydroxyl group react. But see, after reactions what happen? If this 2 and 4, if this 2 and 4 means this 2 and this 4 OH react with benzaldehyde, then this type of structure formed. And see this 4 and 2, and in middle there is one carbon containing OH in equatorial position. So if benzaldehyde react with this two OH group which are 1,3 position, then this type of structure, formed. In this structure, see, this 6-member ring is highly strained 6-member ring. This 6-member ring after formation, after reacting with benzaldehyde, this 2, 3, 4, 2, 3, 4, one OH, this OH, on OH, this OH react with benzaldehyde to form a 6-member ring. These are the 6-member ring, new 6-member ring. So these are the new 6-member ring. So this 6-member ring is highly strained. So this whole structure is somewhat unstable because of this highly strained six member ring. So the new six member ring is highly strained, so the whole structure become unstable. Now if the hydroxyl group at 4 and 6 position, 4 5 6, these are also 1 3 diol. So if 4 6 hydroxyl group react, then see what happen. In chair form 2 3 4, 4 hydroxyl group means this hydroxyl group lower, 5 6 this 6 hydroxyl group react. So see, if 4 and 6, if the hydroxyl group hydroxyl group um, positioned at 4 and 6 6 6, this if the two hydroxyl group at 4 and 6 position react, then after reacting with benzaldehyde, a 6 member ring form, and that 6 member ring is very stable 6 member ring. This is a very stable 6 member ring. And see the overall structure is somewhat like a chair rest above another chair. This is a chair, this is a chair form, rest over another, this chair rest over another chair form. So this whole structure is stable. So this is the main reason these two are cis, completely cis. Still benzaldehyde uh, does not react with these two hydroxyl group, rather it react with 4 6 hydroxyl group, 4 and 6 position hydroxyl group to form a stable stable structure. This structure is not stable because the newly formed 6 member ring is highly strained, so that's why the whole structure become unstable. But in this case, the newly formed chair structure is also normal chair like structure, so the whole structure is stable. That's why when this pyranoside react with benzaldehyde, not the cis hydroxyl group, the the one hydroxyl group is lower, and the and this hydroxyl group react. So these are also one three diol compound, and these two hydroxyl group react, not 4 and 2, these two hydroxyl group. So this is the concept and this is the very concept. So we will see in our upcoming video, there are many type reactions of this molecule. After protecting this two hydroxyl group, we can perform any reactions regarding this. We can perform any protection reactions, because if these two hydroxyl group are protected by benzaldehyde, then this two OH group free. So we will see in our upcoming video, there are a lot of reactions by after protecting uh, pyranoside using benzaldehyde. We will see there are a lot of reactions can be performed. uh, this molecule, we will take this molecule, and we will see there are many reactions which are performed uh, upon uh, which are performed on this molecule. So we will see in our upcoming video. So the if we draw the structure like that, this is the structure. And also see in this case, the pH phenyl ring and hydrogen ring, we cannot say that this phenyl ring rests in a axial or equatorial position, because this whole new chair is somewhat different chair like. So this chair is not normal chair, so we cannot see the pH is axial or equatorial position. But see, in this case to gain the stability, the pH phenyl ring automatically positioned at equatorial position, not axial position. That's why the pH stoichiochemistry should be below. So so we have to remember two things, that this hydroxyl group and this hydroxyl group react with benzyl will react with benzaldehyde, not this 2 cis hydroxyl group. And also the phenyl group, the phenyl ring or any other the phenyl ring should be below, because in this 6-member ring the phenyl ring automatically positioned at equatorial position to gain stability. It cannot rest at axial position. So since it positioned at equatorial position, so pH stoichiochemistry should be below. So I think you all understood what I am trying to say. I am just repeating within by taking 1 minute another. So this is glucopyranoside alpha or beta, whatever. Benzaldehyde react with 1,3-diol to protect 1,3-diol. Use benzaldehyde. In this compound, there are two type benzaldehyde. 2 4 position ben there are two type 1,3-diol. 2 and 4 position, these two hydroxyl group are at 1,3-diol, and 4 are 6 and 4 and 6, these two hydroxyl group are at 1,3-diol position. So benzaldehyde, if benzaldehyde react with these 2 and 4 which are in cis manner, and that is a necessary criteria, the cis the 1,3-diol should be cis, then the reaction will proceed easily. So if this cis 1,3-diol react with benzaldehyde, then we will get a highly strained molecule. This molecule is highly strained molecule. That's why still these are cis on trial, still benzaldehyde cannot react with these two hydroxyl group. Rather benzaldehyde react with 4 6 hydroxyl group which are also 1,3-diol to give a stable molecule. There are two chair, like one chair rest to another. So when the 4 position and 6 position hydroxyl group react with benzaldehyde, then we will get a stable molecule. There are two chair form. Both chair are normal, exist at normal chair form, and also the phenyl ring is equatorial position. So the phenyl ring should be below. So this is the final product of the reactions. So now we will see the questions recently asked in the recent CSIR NET 2021 June exam. So they just they just gave a normal cyclohexane, substituted cyclohexane, not a glucose kind of compound, but the concept is same here also. Same concept is applicable here also. See, if we draw the chair form, then this 1 2 3, one hydroxyl is above, 2 CH2OH above mean equatorial, and 3 hydroxyl group is equatorial, means below. So if benzaldehyde react with 1 2 2 dash, I marked this carbon as 1, this is 2, and this is 2 dash. If benzaldehyde react with 1 2 dash hydroxyl group, means 1 2 3, this hydroxyl group 1 and 2 dash hydroxyl group are 1,3-diol. If benzaldehyde react with this 1,3-diol, then in this case a strained 6-member ring is formed. Same thing, same concept, same situations arise here also, but they change the structure. They did not give the glucose ring, but they normally gave a cyclohexane, substituted cyclohexane ring. So same concept is applicable here. See here, the newly formed cyclohexane ring is highly strained. That's why the whole molecule is unstable. If benzaldehyde react with 2-3 hydroxyl group, see 2-3 2 dash and 3 position hydroxyl group also 1,3 diol 1,3 diol diol. So if this 1,3 diol react, then we will get a stable molecule. Stable means these two cyclohexane are exist as normal cyclo normal chair form, and obviously in this case also the pH should be at equatorial position. So see, the same, they gave a different compound, but in this case the concept, same concept will be applicable in this case also. So by by seeing the compound immediately, one can imagine that since these are cis 1,3 diol, so this diol will react with benzaldehyde, but not if we draw the chair form, and after reacting with benzaldehyde, if we draw the molecule, then if this cis 1,3 diol react with benzaldehyde, then a highly strained six member ring is formed, will which because of which the whole compound become unstable. If the trans trans means these are not completely trans, this is below, this bond is above, and this OH is plane in plane, so these OHs are not in cis completely, not in completely trans, but still if this 1,3 if this 1,3 if this 1,3 if this so in this case this OH group, I forgot to mark this OH group, so this should be 2 dash, or you can mark any number. So this OH and this 3 hydroxyl group, if react with benzaldehyde, then we will get 2 stable chair form, and the overall whole molecule is become stable. So if one can think that if this 1 2 3, if this 1 and 3 position 3 hydroxyl group can it is possible, it is impossible. These are completely trans. See in chair form, 3 OH is here and 1 OH is up. The distance between two OH is very large. This 2 OH group rests far from each other, many far from each other. These two OH group are uh, far from each other, so there is no questions about this 1,3 diol to react with benzaldehyde. There is no questions. So so it is a wrong thing that we can say like that. Is it possible to one to react with benzaldehyde this 1,3 diol? It is impossible. So it is impossible for this 1,3 trans diol to react with benzaldehyde. So it is impossible. So another thing, this is the compound. Another thing, you I draw this chair form in different way, and and draw the compound, the final compound after reacting with benzaldehyde. You can draw the uh, this molecule in a different way also. This one weighs above, 2 CH2 weighs above, this OH is below, and this OH is below. So if this chair form is formed, if we draw this chair form, and if 1 2 3, if 1 and 2 dash OH means this 1 3 diol react with benzaldehyde, then see in this case two chair is formed. So in this case two chair is formed, but this chair is somewhat stable, not that much strain. This chair seems like normal chair, but this whole structure seems like uh, cis-decalin kind of structure, but in this case the pH and hydrogen also we cannot sure that where the pH we put the pH where and A is where. So cis-decalin is unstable than cis-decalin is less stable than trans-decalin. So this structure, this six member structure is somewhat like trans-decalin, and we all know the trans-decalin structure is more stable than cis-decalin. So there is no, so it is a wrong thing actually, logically, to compare with trans-decalin and cis-decalin by this, but that's for comparison. This system, this chair form is this compound. In this compound there are two chair form, but still this chair form is not a perfect chair, and this compound is seems like a cis-decalin molecule, and it is unstable, and this compound is a trans-decalin, so it is trans-decalin kind of, so it is stable. So previously I draw this molecule, this is a stable molecule, because see, 1 OH is above, 2 OH is above means this CH2OH is equatorial, and I draw 3 below equatorial. So here only 1 OH is axial, 2 substituent is equatorial. That's why I first draw this chair form and showed the reactions in this chair form. If one can assume that if this chair form is possible, then we will find two stable chair like form. But yeah, in this case the chair, we can see that the chair is formed, two chair is formed, but still uh, this whole geometry is like a cis decalin kind of geometry, so it's unstable. And also see, this is unstable. So this cyclohexane, substituted cyclohexane, cannot exist in this form, because see, if you draw this structure, then one OH is equatorial, this CH2 is axial, and this OH group also axial. Because if you put one in equatorial means above, then this CH2 should be above means axial, and this OH should be below. Below means this axial group. So this cyclohexane chair form is unstable. So there is no questions for the formation of this compound. So for just confirmation or further clearance, I again draw this structure and try to show the possibility. So this molecule react with this chair form, and the benzaldehyde react with this OH and this OH. Obviously, in also this chair form the pH should be equatorial. So the final product is like that. So the stoichiochemistry here also, we have to mention the stoichiochemistry here also. The pH is below and hydrogen is above means hydrogen axial. So this question was asked recently in 2021 exam. So maybe uh, from this these questions, so they can change the molecule. If for next time they can set this molecule using the glucose moiety or glucopyranose or glucopyranose, and if they give if they will set this reaction, so we can easily predict the answer. So I think you all understood what the uh, actual concept I am trying to say. So I think, I hope all of you understood the point. So thank you for watching. And another point I have to mention that I uploaded on video regarding the reactions of reaction of D-glucose with excess acetone, and regarding that questions asked 2020 GATE exam, that was also a very conceptual reactions, and a very conceptual reactions from carbohydrate chemistry. So uh, we uploaded one video, and after reacting the glucose moiety with ketone. So ketone means 1,2-diol protection will be occur there. So after protecting 1,2-diol by ketone, we get we we will get a molecule, and in this case, after protecting glucopyranoside by benzaldehyde, we got a protected molecule. So in our upcoming video, we will see, by taking those two compound, means after protecting this molecule with benzaldehyde, this is 1,3-diol protected compound. So we will take one compound, and from my last video, that is the 2020 GATE, that I solved the questions and already discussed the uh, every concept regarding that questions. So in our upcoming video, we will see many reactions regarding these two compounds. One compound is this, one thread I have protected, and another compound we will take from our previous video, that is after protecting with acetone, of glucose, that protected version of glucose we will take, that protected version of glucose with acetone, and that protected version of glucopyranoside with benzaldehyde. we will took we will take these two uh, molecule, and we'll see lots of reactions we can perform upon this molecule. So thank you for watching. Stay safe, stay healthy.